Hi, my name is Osman Ali Ibrahim al-Shabab. I'm an architect and urban planner. I'm from the city of Baghdad, Iraq. I'm starting my PhD program at Okan University in the city of Istanbul, Turkey. Today I would like to discuss my research paper, which is a building as a system, a review of building integration through pre-formative design. Let's go through the slides. Hi again. As we mentioned, our research is about a building as a system, a review of building integration through pre-formative design. The recent need of more buildings have developed across the world, which are mostly in the form of cooperative projects. It has been as a trend to forecast, continue well, and not stop in the near future. Many cities now seek to increase housing development in a form of a strategy. However, taking advantage on existing infrastructure to support that growth is a global issue due to its increased population. As a result, science needs more workable cities that privilege its pedestrians rather than its vehicles. In addition, this is widely known as a contribution for any improved quality of urban life. If residential buildings are becoming the main form of new development in urban cities globally, then it is important that real estate development should contribute in improving its dwellers' life as they do for neighborhoods and surroundings. This paper will try to describe the building as a system through integration between passive and active system design as a pre-formative approach that ends with a set of design guidelines and conclusion. The main research keywords are building as a system, a pre-formative design, building integration, passive and active design. As an introduction, this research emphasizes on how to deliver a better building design approach. The objective of this paper is to help acknowledge architecture designers with up-to-date building science information in order to help them improve their design projects to reach and enhance sustainable outcome, which, as we know, it can be achieved in steps or main factors. So, to achieve this approach, we need to understand or tackle these 5 issues, which is related to 1. Developing energy and water efficiency, 2. Promoting inhabitant comfort and well-being, extending durability and serve life, reducing energy demand, resilience, thermal comfort, and passive. By addressing these issues as an opportunities for improving housing design, architects gain awareness of the key parameters that are vital to sustain building projects in the future. Now, what is pre-formative building design? The main approach to the design and construction of building has been, as we know, build cheap, maintain expensive. So, preformative Preformative is referring to a high design that embodies integration and optimization process through all its major features, such as energy management, security, flexibility, accessibility, value, efficiency, sustainability, and functionality. Architects and designers should try to establish an understanding to indicate how to use the design stage throughout construction and operational stage. Due, due to that, the above can be considered as key parameters for a successful design. Therefore, professionals seek to reach the sustainability and equality by assuring the needs of all future generations. So, coming back, the building as a system. We need to understand the building as a system, which is achieved by understanding its concept matter. The idea of a building as a system springs from modern system theory and the application of building science principles to buildings behavior, and which is, as we mentioned, is related to building behavior and performance. The building as a system approach requires designers to clearly consider the integration between the primary elements involved in the system, as shown below, which is related to building enclosure, inhabitants, building services, the site, and the exterior environment. The building as a system, and as we can see and show in this figure, is giving us an insight how to link the other factors through the building. So, buildings are linked together with occupants, mechanical systems, and its environment. And these four are linked twice together and must be dealt in parallel situation to solve or minimize the effect of negative issues, which is related to pollution, heat, fire, moisture, and cost and heat. What is passive and active role in buildings? To understand the integration and to understand the building as a system, we need to understand the relationships and the role playing in buildings. So, what is passive and active role in buildings? Passive role is to moderate the environmental through health, safety, and delight. Passive system design is in mainly deals with natural ventilation, providing fresh air and minimizing the effect of moisture. Second is passive solar, which is related to thermal control. Daylighting, which is related to the providing the amount of sunlight needed during the day. We can see here a figure which explains what we have elaborated earlier, which is, as we can see, is related to here. We can see the daylighting, which is providing sun and glazed areas, which that sun and sunlight can enter to the indoor environments. Here is related to passive solar, which is minimizing the effect of the solar on buildings, providing ways that can benefit from the natural ventilation or wind or fresh air to enter the indoor environments. On the other hand, active role play a much more mechanical uh, part of the building. Its, its, its main role is to supplement the desired level of environmental control and function. This can be achieved by active system design, which is related to heat filtration and accommodation system, which is and second related to mechanical ventilation strategies. Third, individual central control, operative and control, and thermal comfort. Here we can see a figure which displays the active system design in buildings. We can see it's related to PVC area, mechanical concerns, duct and piping. So the all needed the all needed mechanical systems or electric or control platforms needed to control the indoor environment of the building. Therefore, it's related to the active system. It's much more not a natural, much more artificial. So, now we can understand building system integration. So, the common purpose of building science is to achieve building system integration. This involves levels of performance that can be achieved by assuring inhabitant compliance, optimizing performance, which goes beyond compatibility between the structure, enclosure, and interior and services. Also, economic, social, and environmental parameters are known as performance targets within the skill capacity of the industry. This means innovation is a key factor in reaching integration through building design, which will help achieve better performance and high quality production at less cost over the life cycle of the building. Subsystems involved in building system integration are architecture, interior, enclosure, and services. All of these factors are linked together in a more 3D shape, which is, when applying time, we need to act according to those four when designing a building. Now, after in our research, we have gave some design guidelines which are very important to upgrade our housing, multi-rise residential buildings, which is, classified in 10 main guidelines. The first one is about scale, and typology guidelines, which is related to the dimension of block buildings, and how to break down the building to give much more vocal point, and same time change the urban planning pattern of the city. This will help to improve the building design and give a good insight for the skyline of the city. There's many examples for that. I cannot explain it all, but you're gonna have a copy of my presentation, and you can study it much more further. The second one is about massing guidelines, which is related, as we all know, to vertical and horizontal dimensions, making the building much more unique and much more parallel. Sometimes simple is good, but sometimes not just simple, because we need to make some activity of relations between occupants and the building itself, and so which will make the building much more valuable for all. The third one is related to the orientation guidelines, which is, as we know, the direction the building faces, the level of shadows, the position of the building, and the enclosure within the outdoor environment. And the fourth one is related to structure guidelines, which is, as we all know, is related to some physical elements that we need to provide, such as flexible units and thermal breakers for balconies and extra. The fifth one is related much more for the unit guidelines, the proportion, the windows, the corner, how to improve our design through this stage, to think in much more detail how to improve our building or housing units. The sixth one is related to materials. So, to act more responsible for the environment and provide a fine design, we need to think about the materials that we use. We try to minimize the usage of glass in buildings, make the material selection much more locally in the cities, use much more bright colors or less than dark, and so therefore it will help us to improve our design in the future. The seven is much more related to the accessibility of the building, making the doors much more clear, using not to use visual staircases in the building, sometimes making that, skipping a spot place through the building. It will help the building have that energical side of it. The eighth one is related to indoor and outdoor guidelines, which is related to green courtyards. We need to to make that relation between outdoor and indoor, and this can be achieved easily by addressing buildings as a window to view all the good things, which is helping the inhabitants feel much more connected to the outdoors environments, which can be related to easily by appointing some green courtyard, sorry, in the building, and making uh, links between indoor and outdoor environments. The ninth is really related to the solar access guidelines, which is, as we know, helps the health of the inhabitants and feel much more connected. So we need to think about reducing the bad effects of sun during summer and allowing the sun to enter during winter. That will help in giving the feel of and thermal comfort and well-being, and using materials that will reduce the effect of solar solar access through the buildings. The 10th and the last guideline is related to day lighting guidelines, which is as it's just like the solar guideline, which is related to the usage of sun in the indoor environment. This will help improve our designs and at the same time improve uh, improve the health of the inhabitants. So we need to think about views, we need to think about shadows, we need to think about the amount of sun is entering the indoor environments. This all will benefit to make much more will benefit our design and give it much more value in the future. As a conclusion for the research paper, uh, thermal comfort is becoming an issue in residential buildings, especially with full glazed walls, because they are humbly thermal efficient, and over time they are unsecured for moisture and air leakage. Therefore, they will need to be refitted and at a considerable expense and will be uncomfortable. New modern building design need a better enclosure performance to avoid thermal leakage and to be able in controlling airflow that affect indoor thermal comfort. The selection of appropriate passive building devices act as a building design strategy to avoid discomfort situation. Designers should use suitable heat conducted system to achieve better enhanced comfort. Using using detect, using dedicated and smart ventilation systems will help in recovering the extra energy or heat in a closed loop so the indoor environment will not be uncomfortable. The key element of success for this approach is the inhabitants. Therefore, comfort is easily achievable if educating the inhabitant in concerns of HVA systems, adjusting shading device, and the opening or closing of windows, according to the year's season, which will help mediate the comfort coordinator in housings. Building is a system that must be integrated from the design stage, together by designers and engineers. to achieve the needed level of performance. New building science is trying to deal with physical requirements of buildings that is compatible with all project process. Addressing innovation as a goal in new modern architecture depends on building science and this and its changeable approaches to reach building performance that need all building stakeholders, such as building owners, inhabitants, and society, to be involved through its early stages. The context for building performance has recently evolved to include issues of ecology, sustainability. This expansion of performance parameters with increasing consumer expectation has dramatically increased the complexity of buildings. Performance objectives, frameworks, and conceptual models have become necessary. Methodologies necessary. Methodologies to assume all aspects of the integration of well-performing building system has been carefully addressed. New building science has evolved beyond simple analyzing, and now it offers a range of classy design tools, testing protocols, and performance simulation techniques. These have become vital additions to professional experience and critical remark of actual building performance. The role of new modern design science within architecture and engineering continue to support the dynamic relationship between theory and practice in the industry. This is the set of references that I took, and I'm open for any discussions and any questions that need, and I can provide you with the researches that I studied, and I thank you for your patience and time, and I hope you enjoyed my research. Thank you.